All right, let's go ahead and do this warm-up before the quiz, and one last attempt to get you to have a good understanding of the normal model. All right, so on this warm-up, it has this first page. It's about transformations, and so since that wasn't really in this unit, we're going to go ahead and skip that page and not have anything to do with that. Now, yep, we're going to skip that whole thing because I think we can get everything from the rest of it. So here, this first problem, number 2 on this page, had your comparison of a Dalmatian and a boxer. So now remember, whenever we're comparing two totally different things, we need to get their z-scores. We have to standardize their scores so that we can get those values, so we can compare them. So when you have that situation, you're going to take the Dalmatians and you're going to write down all the facts that you have for them. You have the mean, the standard deviation, and the context value. We'll get the z-score for that Dalmatian with your x minus the mean over the standard deviation, x minus the mean over the standard deviation, okay? And then do the same thing for our boxers. Get the mean of the boxers. Standard deviation, x, and we'll x minus the mean over the standard deviation is the z at that spot. Now that we have these two values, we want to compare them to see which one is more standard deviations away from the mean. Now in this case, they both are below the mean. And so the more underweight dog is the boxer in this case. And the reason is because it was more standard deviations below the mean. All right, now here you have to read carefully. Man, that is just one thing that you guys, I think you look at the paper and you just don't even dive in to start reading it. Or at least the students that I've seen have trouble. Just don't dive in and start reading and comprehending what it says. So this is talking about the average temperature. You know, they've been taken with the mouth or they're taken with the ear. So with the ear thermometer. So when it was taken with the ear, it's typically half a degree higher than when it's taken with the mouth. And so the average mouth temperature is 98.2. So therefore, they're saying, all right, let's say the ear temperature is 98.7 with a standard deviation of 0.7. All right, so your things you got to do. Define x. X is the body temperature taken with the ear. Number 2, define the normal model. The normal model with a mean of 98.7 and a standard deviation of 0.7. Number 3, define what you are looking for. In this case, I'm looking for the probability that I get a temperature below 97. That was the third thing. Number 4, draw a picture with the mean and the cutoff, the boundary, and any area. Number 5, get the answer. So when I went and I did this in Desmos, I got 0.0075. So that's it. You don't have to write this answer here in context, okay? All right, now, we did not get to this yesterday in class because I was just disappointed with how far off we were from everything, and we only got through the algebra of solving for the mean and standard deviation. But I'm going to throw this at you. I think it's something you can definitely do. So find the interquartile range. Well, Q1 will be at the 25th percentile. So you go and you get a z-score for 0.25 to the left. 0.25 to the left z-score is negative 0.67. And now you put this in the z-score formula and solve for Q1. You then get the z-score for Q3, which is 75% to the left. So you do that, and that's a positive 0.67. The z-score for 75% to the left. Q3 solving is then 99.7. So the IQR would be your Q3 minus your Q1. And there you go. So the middle 50% span 0.94. All right, so this question here definitely will not be on there. It has a missing mean and a standard deviation, so we're going to skip that. All right, now we have context problems. So this is very typical of the kind of information you have to do. Read the problem. The stopping distance they want is a limit of that 291.2. So x is the yards traveled by this golf ball. The normal model with a mean of 288 and 2.8. So that's the second thing you got to include. The third thing, what is it that you're finding? We're finding the probability that x is greater than or equal to 291.2. Traveling too far means past the 291.2. 4, draw a picture. There it is, and I want this area here, and then I put it into Desmos, and there's the answer, 0.1265. You do not have to write it in this context value here. Next, C is saying, what if we changed the mean? So this is like yesterday, but we had talked about, but we are wondering, what can the mean be set at so that 99%, so I want the boundary of 99% to be that 291.2 or less. So that says that the z-score, so if you do the normal model to find the z at that spot with 99% to the left, that is 2.33. So here's my x minus the mean over the standard deviation, and then I'm going to do algebra to solve for that mean. So I'm going to multiply by 2.8 on both sides, and I get this 291.2 minus the mean equals 6.52. I will get this, subtract that 291.2 over, because what's in front of it is a plus sign. So I'm going to subtract that over, and I get this negative 284.68 equals the negative mean. Well, when you multiply through by the negatives, mean is 284.68. All right. So next, here is another statistics problem. What's the 70th percentile for stopping distances? When you read here, you can see, here's the context. Thing number one, state the context is the stopping distance in feet for the new all-weather tires. Number two, state the normal model you're using. I'm using a normal model with a mean of 125 and a standard deviation of 6.5. Number three, tell me what you are finding. I'm finding x with 70% to the left of it. 4, draw a picture. So I have this picture here with 70% to the left of the unknown x. 5, answer the question. So I went and I put this into Desmos. Why do I not have a picture of the Desmos that I put in here? But anyway, I don't. So I just did normal distribution, normal dist with this in the Desmos, and I found bound, so I did boundary with 70% to the left. All right, so that became 129.41 feet. And the last one, well, no, we still have several more. Okay, next we have X is the weight of a full carton of grade A eggs. The normal model is defined as 840 for the mean and 7.9. 3, state what you were trying to get. Probability that X is greater than or equal to 850. Number 4, draw a picture right here. And number 5, answer the question. So see, this is how you do that probability, normal distribution, 8 of that, and I went to the right and I found the area to the right. All right, and the next one here we have X is the number of days students are absent, defining that context. N is 120 and 10.5. 3, tell me what you want. I want the probability that X is greater than or equal to 140 because that's when we're going to lose funding. 4, draw a picture. 5, give the answer. So I went and I did that in Desmos, and I did the area to the right was 0.0284. All right, and I think there's one last one on this next page. What are we finding? X is the weight of the melons from distributor J. The mean of 133 and a standard deviation of 5. Find the probability with X is greater than or equal to 137, and 4, draw a picture, and 5, get the answer. All right, so there you have it, and there's what it looked like in your Desmos. We were finding that probability. Okay, please work on those and make sure you are including all those 5 things. State the context of X. Define the normal model you're using. State what you are finding, whether that's probability notation or finding something else. 4, give me a picture. And 5, give me the answer. Alrighty, that's all I have to say about that. So good luck with you, and good luck on your quiz.